This is Gemini Control, Houston. McDivitt confirms that White did leave the spacecraft. He says it looks great. He's outside working his maneuvering unit. And Jim is quite exuberant about the performance that he's witnessing at this time.
Being in a spacesuit, one of the things you first notice is you're very separated. Once your helmet goes on, you can't hear the things outside of you, so you realize that you are your own enclosed environment. After that, you have to kind of learn how the suit moves. You cannot make a spacesuit move in a way it's not designed to move. So the more you fight a spacesuit, the more tired you're going to get.
You got about 4 minutes till Bermuda LOS.
This is Jim. Got any message for us?
The flight director says get back in.
Jimmy 4, get back in.
Okay.
Spacesuits look like spacesuits for a reason. We don't make spacesuits to look cool or spacey or futuristic, any of those things. Job number one with a spacesuit is keep the astronaut alive. So spacesuits look like spacesuits because that's the job they do.
This is NASA's Curious Universe. Our universe is a wild and wonderful place. I'm your host, Patty Boyd, and in this podcast, NASA is your tour guide. Space is an amazing place to visit, but it's also extremely dangerous. Depending on where you're traveling, the space environment can be very cold or very hot, and there's no air to breathe. To venture beyond Earth's atmosphere, you're going to need protection. For astronauts, that protection comes in the form of a complex, human-shaped spacecraft, a spacesuit. There's a long legacy of lunar spacesuit design at NASA, going back to the first spacesuits worn on the moon during the Apollo program. The next time astronauts walk on the moon through the Artemis program, they'll be wearing new spacesuits designed by NASA collaborator Axiom Space. Today, let's learn about the crucial role NASA spacesuit engineers have played in designing new technologies and experimental spacesuit prototypes that will keep our explorers safe on the moon and beyond.
Space is not an environment that is made to keep people alive. The thermal environment, the vacuum environment, so no air, radiation, all those kinds of things are not there to give you a happy home. My name is Amy Ross, and I am a spacesuit engineer. Basically, a spacesuit engineer builds human-shaped spacecraft. Our spacesuit provides basically the same things that a spacecraft like the International Space Station provides. Keeps you alive when you're in space and allows you to do work while you're in space.
Spacesuit engineers have to consider a lot of hazards when designing those human-shaped spacecraft.
For example, you're on the space station or even the sunny part of the moon. That sunlight coming down can make things very warm on the order of like cookie baking temperatures.
Since the moon, unlike the Earth, has no air layer to absorb the sun's rays, temperatures can reach 250 degrees Fahrenheit, well above the boiling point of water.
But then on the flip side, as you rotate on the space station, for example, around to the shady side of the Earth, then it can get really cold, like lower than Alaska in February in a snowstorm.
The lunar night would hold an additional peril, the intense cold of space, minus 271 degrees Fahrenheit.
What we do is we create a little bubble or balloon around the human that creates that environment that we need and are used to breathe and operate and be alive so we can then do some work.
Spacesuits, these personal spacecraft astronauts use to work in space, come in a few different varieties. The bright orange one that astronauts wear when they're strapped into their seats in the capsule, ready to launch to space? That's called a launch and entry suit, or a crew survival suit. These suits don't have a big backpack of life support equipment because they're worn inside a spacecraft.
If you lose cabin pressure, during dynamic phases of flight, so launch, landing, docking, those kinds of things. That suit provides pressure on the body, which provides also oxygen that you need to breathe, and that keeps you alive. But in general, that suit is worn unpressurized, and you really only need it if there's an emergency.
Then there's the big white spacesuits, the ones you may have seen astronauts Neil Armstrong and Buzz Aldrin wearing in the Apollo 11 moon landing footage.
Neil Armstrong's been on the lunar surface now almost 45 minutes.
Columbia, this is Houston, reading you loud and clear, over.
Yeah, reading you loud and clear. How's it going?
Roger, the EVA is progressing beautifully. I believe they're setting up the flag now.
Beautiful, just beautiful.
These suits have a big backpack that contains all the life support systems the astronaut needs to stay alive on the moon.
An extravehicular activity suit, or EVA suit, that's the one that you wear when you go outside and do work while you're already in space. You're building space stations, you're walking on the moon, you're looking for life on Mars, those kinds of things. And that suit is worn pressurized, always.
There are two kinds of EVA suits, which astronauts use for different purposes. One of those suits works best when you're getting ready to visit a planetary body that has gravity, like the moon or Mars. The other one you would use when working outside a spacecraft, like the International Space Station, during what's called a spacewalk.
Now you can have a microgravity EVA suit, so a suit that floats on the space station and you do most of the work with your hands.
You'll take that adjustable around the handrail and back to the tether point, and then I'll have some more words for you in a moment.
Okay, copy that. Didn't work.
Or there's a planetary walking suit. You go out for a stroll on the moon or Mars.
I'm going to step off the limb. It's one small step for man, one giant leap for mankind.
Astronauts have used one microgravity EVA suit called the Extravehicular Mobility Unit consistently since the 1980s for spacewalks in low Earth orbit. But planetary walking suits are much less common. In fact, the moonwalking spacesuit designed for the Apollo program, the last time we went to the moon, is the only surface walking spacesuit ever made.
American astronauts will explore the moon. When they do, their lives will depend on a mobile and self-sustaining life support system called the Apollo Extravehicular Mobility Unit.
The Apollo suit really was a combination of a crew survival suit, a microgravity EVA suit, and a planetary surface EVA suit. When you want one piece of hardware to do multiple different types of jobs, that means it tends to not be good at everything as the gold standard.
Dave. Hang on. Yeah, I lost my balance.
Spectacular demonstration.
Those Apollo suits weren't easy to move around in. The astronauts wearing them had to hop across the moon's surface because it was hard for them to bend their legs.
Rather careful to keep track of where your center of mass is. It takes about 2 or 3 paces to make sure that you've got your feet underneath you.
And the suits weren't designed to hold up against rough lunar dust for more than a few days.
I think you've got a lot of it on you, too. Looks like you guys have been playing in a cold bin. I don't know how we're going to get it off. Let's do the best we can.
With the Artemis program, which you may have heard about in a previous episode or two, NASA is going back to the moon to establish a long-term presence, and then on to Mars. So it's time for a brand new suit, one that will enable a new era of human space exploration. Amy's team started that process by designing a prototype called the XEMU. Now, Axiom Space will build the spacesuit NASA Artemis astronauts will wear on their first return to the lunar surface since the Apollo program. To do so, they will have access to the XEMU data and hardware, along with over 50 years of spacesuit experience from NASA.
When we're going back to the moon and we want to try to spend a lot of time there, build a moon station, moon base, and be there for extended periods of time, you're going to want to build a suit that's more focused on that mission.
Whether you're going to the International Space Station, the moon, or Mars, when it comes to designing a new spacesuit, the first thing the suit designers have to consider is the destination.
Where you're going and what you're doing change what your suit looks like. Say you want to go on a vacation. There's some basic information you need to know before you pack. Am I going to the beach? Am I going to Alaska? What am I going to do while I'm there? When you're on a microgravity space station, like the International Space Station, you're not really walking anywhere, and your boots are really more of a hard, flat interface that allows you to get into a foot restraint and be stable. But if you're going to go hiking over rocks and up and down hills and into ditches on, say, a Martian or lunar surface, then your boots need to look very different, as does other parts of the suit.
Designing and building a new spacesuit involves quite a bit of testing, but you can't always do that in space. One way to figure out what a suit needs to be able to do is to send scientists out into a similar environment here on Earth and watch them work. That's called an analog test. It's conducted in an environment on Earth that simulates the lunar surface. Amy was a member of a NASA team that recently completed an analog test in a desert near Flagstaff, Arizona.
And one of the things we were trying to do there was understand what kind of requirements we had for exploration suits. We put geologists into spacesuits and asked them to do geology, because that's one of the big jobs we're going to ask our astronauts to do when they go to the moon and onto Mars.
During analog tests, Amy and other NASA spacesuit engineers watch spacesuit-wearing scientists do geology in the field, keeping a close eye on their movements and asking lots of questions.
What does it look like for them to try to work on our suit? And then what other tools do they need that we don't currently have in the suits that we can add to help them do their job?
The research gathered during these tests helps NASA plan the Artemis surface missions and can impact the design of the suits and tools used to collect lunar samples. It's important that the final suit design will offer astronauts a full range of motion.
For every joint that you have in a spacesuit, you have to build in the kinds of motions you want. In your elbow, for example, you can build a simple hinge joint, like your door hinge, that allows your elbow to bend. What about something like your shoulder that rotates and can flap up and down and do all these different things? Well, then you have to think about the different pieces of that motion and build each one of those in.
Spacesuit design is a pretty repetitive process. That was the case with the XEMU prototype Amy's team worked on. You build a prototype, let people try it out, and gather their feedback so you can make more improvements.
Put a suit together and then see if it does what you meant for it to do. The interesting thing is you think you've got it beat, and then you put test subject number 12 in the suit, and subjects 1 through 11 were happy, and number 12 comes up with a different opinion. Kind of a loop there for a while, building and then testing and then improving and building and testing. And the engineers have to be told to stop at some point, and you need to get something ready to fly.
Beyond letting humans try on spacesuits, we're also sending parts out into space to see how they hold up. Part of the NASA prototype spacesuit recently hitched a ride on the Perseverance rover, which touched down on the red planet in 2021.
Touchdown confirmed. On the surface of Mars. Ready to begin.
We were able to put 5 small samples on this calibration target to start understanding how the Martian environment really does affect our spacesuit materials.
When designing a next-generation spacesuit, NASA and the agency's collaborators have to make sure it works for a broad range of astronauts, each with unique body types. That was not the biggest consideration during the 1950s and 60s, when all of the astronauts were military test pilots of about the same size and weight.
In the Apollo program, they had customized spacesuits that were molded to the body. They actually almost mummy wrapped them and then did a mold of the human.
The new class of Artemis astronauts is NASA's most diverse class to date. It includes astronauts like geologist Jessica Watkins, medical doctor Johnny Kim, marine biologist Jessica Meir, and nuclear engineer Kayla Barron.
Now, when we have this focus on the skills of the crew member and we just need to fit a spacesuit on whoever we need to fly, we need to be able to fit a wide range of people with as little different pieces of hardware as you can.
With a modular approach, We can swap different parts between different astronauts' suits as needed. The suits aren't specific to one astronaut anymore. That's important because these spacesuits will have to be used over and over during astronauts' sustained presence on the moon.
When you're far away from home, you can't have 100 different unique spare parts that you need to have with you. You need to have 3 or 4 spare parts that you can use and swap and fix and go outside and do your job with.
When it comes to living and working in space, every single piece matters. Current EVA spacesuits have 3 main components. First is the pressure garment, the part that the astronaut actually wears like clothing and has to be able to move around in.
The Apollo Extravehicular Mobility Unit, or EMU, is actually made up of several major components. These include a pressure garment assembly, including helmet, boots, and gloves.
And that's the part that I work on. It's got an upper torso, which is your top. It has arms, gloves. Then there's your waist and your lower torso, your hips, your legs, and then your boots. You also wear an undergarment under the shell of the spacesuit that provides liquid cooling.
The cooling garment will be worn under the pressure garment to carry off the astronaut's metabolic heat.
We don't have air conditioning in the suit. We use cool water flowing through tubes to help cool you down. Think about being in a VW Beetle with no air conditioning and windows up. It's going to get hot fast.
Another feature of the NASA prototype XEMU suit is the Portable Life Support System, or PLIS. It's a big backpack full of fans and pumps that circulates air and water through the spacesuit.
The Portable Life Support System weighs approximately 50 Earth pounds and will be used on all extravehicular missions.
The Portable Life Support System has batteries and radios and oxygen and pumps and fans and cooling systems and all those kinds of things that help keep you alive. It gets the air kind of circulated around, cleaned up again, so you can use the oxygen that you can reuse again.
Columbia, this is Houston, over.
1 hour and a half expended on the PLSSs now.
While the XEMU team worked to pack fans, pumps, and more into the suit's backpack, the pressure garment team Amy worked on faced a different challenge: creating a flexible suit that's comfortable enough to wear and can protect astronauts in the vacuum of space or on the freezing, baking, airless surface of the moon. This is the same challenge private companies will face when making the next generation's suits for the Artemis mission.
When you work on the pressure garment, it's a system that's made up of partly fabric, like sewn together pieces. And so trying to make that structure out of soft goods, and then we can also use composites and metals, but then make that also fit around a human and allow them to do all the things a human body can do, while it also protects you from the environment of space, gets to be a really fun, challenging problem.
The electrical system is the third critical component of a spacesuit. It's what allows an astronaut to interact with their own personal spacecraft. On the XEMU, for example,
you have controls on the front of your suit that you use to turn your suit on, right? You turn the battery power on, you turn your pumps on, turn the volume on your radio up, those kinds of things. And that's part of our avionics system.
The Artemis suit's avionics system will be essential. On long-term trips to the moon and faraway Mars, communication with mission control on Earth will be limited, so astronauts will need to have more control over their mission plans and spacesuits.
That's going to get more and more complex as we move to more independent work by the astronauts. So when you go to Mars, you might not get an answer for 30 minutes or more. They need to be able to have more information about their suit and more control over their suit when they have to be more independent like that, because you can't depend on the ground helping you as much.
To help astronauts navigate the surface of the moon and Mars more independently and accomplish their science goals, NASA engineers have prototyped potential new technology for the next generation of planetary spacesuit avionics systems: augmented reality.
In Apollo days, we had to pre-fly and pre-plan a lot of this, and it's really hard to change your plans. With an Artemis mission that enables lifetime updates digitally to the crew member, that would enable them to change their plans on the fly. Let's say they find a geological point of interest, they could immediately shift their focus to that area and plan to go there instead of having to completely replan for another day. Hi, my name is Paromita Mitra, and I am a human interface engineer at NASA Johnson Space Center. I lead a team of engineers who build augmented reality displays for future human spaceflight. If you've ever seen Iron Man or any sci-fi movie, he's got the assistant in his helmet constantly talking to him and got the overlay of the digital information. That's exactly what it is.
Apollo astronauts were working with limited technology. They had to look down at a printed map or read instructions from mission control printed on a cuff on their wrist. Using an augmented reality technology that Paromita's team is prototyping, future astronauts walking on the moon could have critical mission information appear right in front of their eyes. It's called a heads-up display, and NASA engineers think it will be especially helpful when it comes to navigation.
If you open up your Google Maps or Apple Maps, whatever you use, the assistant will tell you to turn left at a McDonald's or turn left at a specific street. We don't have those waypoints on the lunar surface, so then the navigation problem becomes much more difficult.
The heads-up display could give astronauts directions to geology points of interest in real time. Imagine you're on the moon, looking at a digital map, and little yellow arrows appearing on the ground in front of you guide you towards an interesting crater. That would sure make future space exploration easier and more efficient. The next generation spacesuit displays will also incorporate new camera features. The Apollo spacesuits had a film camera, but it was tricky to use because it didn't have a viewfinder. An astronaut could aim their body to take a photo, but couldn't be sure what the camera was capturing. Newer camera features will help astronauts document their surroundings and catalog new objects they may come across on the lunar or Martian surface. But it could also be a huge help to mission control, as the team relies on the spacesuit cameras to monitor what astronauts are encountering in space.
Being able to have a viewfinder on a display would be pretty game-changing. It's really the eyes of the crew member from ground.
With new technologies available today, the display could be controlled in a number of ways. By an astronaut's hand gestures, for example, or even a voice assistant. If incorporated into the final spacesuit design, these augmented reality displays could help bring NASA's spacesuits into a new technological era.
We are changing the way that we interact with digital information. Having a flat panel phone tied to your hand where you're craning your neck down to look at information and then looking back up at your environment, there's going to be a time when we change how we visually see that information.
After years of hard work on the new system, Paromita had the chance to try out a prototype of the heads-up display on the XEMU suit NASA designed.
It was the end of the day, around 6 or 7, and we're able to don the suit. It's just the upper portion of the suit. And the eyepiece was adjusted by one of our lead engineers. She placed it exactly in the eye box that I needed for my viewing distance. I saw the green text overlaying the real world. I used our physical controls to start moving through different menus, through the navigation menu, through the procedures, photography menu. And seeing that in front of me was just awe-inspiring. And it was so intuitive. It felt so right.
Amy had her own awe-inspiring moment. Her dad, astronaut Jerry Ross, flew on 7 space shuttle missions to the International Space Station. Amy helped design the spacesuit gloves her dad wore on a few spacewalks outside the station.
That was the Phase 6 glove, and it was my job to take it from our prototype lab through the certification process and get it approved to fly on a space mission. And Dad flew the first pair of Phase 6 gloves on STS-88.
Deborah Houston for EVA. Just a note of interest, Jerry Ross has now exceeded Tom Akers' accumulated EVA time of 29 hours and 41 minutes. Congratulations.
Thanks, Mike.
I was down in Florida with my grandma watching the mission. He was supposed to wear the old gloves, the current 4000 series gloves at the time, then wear the Phase 6 gloves, and then pick which one he thought worked the best. Well, he wore the Phase 6 gloves, so we decided he thought they worked pretty well.
Deborah Houston, Jerry, it looks like you're standing on a mountaintop.
Tremendous view, Chris.
In fact, he called down from space and said so, which was very cool.
Designing a new spacesuit is no easy task. An effective suit has to move in all the ways astronauts need it to, and contain systems that can allow them to live and work thousands of miles from home. A suit has to help astronauts communicate with mission control and find their way around unfamiliar planetary surfaces. But above all, the new spacesuit designs will have to keep our astronauts safe.
It's not clothes. It is a life support system. If you don't do it right, people will die. We have that at the forefront of our minds because we know the crew members. We work with the crew members. The crew members can be family or friends. We want them to come home, and we want them to come home alive. So that helps keep that thought in our heads, and we aren't designing clothes, we are designing a life support system.
As NASA prepares to send astronauts back to the moon through the Artemis program and then onto Mars, Amy, Paromita, and NASA, along with our spacesuit vendors, will keep working hard to make space a more hospitable place, creating suits that keep our explorers safer and allow them to venture deeper into space than ever before. This is NASA's Curious Universe. This episode was written and produced by Christian Elliott. Our executive producer is Katie Conans. The Curious Universe team includes Christina Dana, Maddie Arnold, and Michaela Sosby. Our theme song was composed by Matt Russo and Andrew Santaguida of System Sounds. Special thanks to Tim Hall, Gregory Wiseman, Rebecca Wicks, and John Stoll at the Johnson Space Center. If you liked this episode, please let us know by leaving us a review, tweeting about the show and tagging @NASA, or sharing NASA's Curious Universe with a friend. And remember, you can follow NASA's Curious Universe in your favorite podcast app to get a notification each time we post a new episode.
Right? A spacesuit for an octopus. Now that would be something fun to do.